thirds are in 6 miles. If you had to rewrite that as a division expression, what would it be? Get it, Marcus.
6 divided by 1/3.
Right, and we did not get to this point yet, right? This is all new now?
Yeah.
Okay. Alright, we're going to continue to model it just to show you how and why that shortcut will work. My fraction bar represents my whole number. So I have how many boxes, obviously? What you're going to do is, as best you can, using a steady hand, break up all the boxes into thirds. Yesterday was by a half, right?
Yeah.
Okay. So about like a third way down, line goes across that way. Well, you have to divide the whole entire section, all 6 by thirds. Now, yeah, you could do it. Did you want to do it this way? You could, but then you've got to do it for every box. Here, one line takes care of everything if we go horizontal. So now, if you look at it, this little piece right here, guys, represents what? 1/3. What about this? What about this? So is it safe to say that all of these is 3 1/3 pieces? You okay with that? Now how many thirds? 3 plus another 3 is? Plus another 3. So now, just so you get back to what we're doing here, you have these pieces right here representing 9 thirds. How many total 1/3 pieces do you have? You can say it out loud.
18.
Therefore, 6 divided by 1/3 is 18. Now, something interesting to look at here. When you have a whole number, in this case 6, and you divide by a fraction that's less than 1, will your quotient be greater than 6 or less than 6? Or less or greater than the whole number? Dylan, it'll always be greater, okay? Whatever this whole number is, no matter what, if you're dividing by a fraction less than 1, your answer will always have to be greater than the original number. Yes, Andrew? That's the shortcut. What you've just done, and we're going to get to it, otherwise known as Unverzachtian theory, is something called multiplying by the fractions reciprocal. We'll get to it. I do want to show it to you with a number line, even just to show you that it takes forever. But I want to show you that any division problem can be modeled with any way. And then you'll realize, okay, well, wait a minute. This takes forever if you didn't do a number line. A fraction bar is a little bit shorter. You could get a common denominator and then divide the numerators. Or you could use reciprocal fractions, which I'm going to see really is the quickest. But I just want to show you that it works. And plus, it's good practice anyway. Anytime you use a number line, you have to get to common denominators. Starting off with 6. What is 6 as an improper fraction? You have to do that first. Now, all right, start with that. Next thing we have to decide between these two fractions, what should our common denominator be? Fill up. Great. Just like we did in our ratios unit. What's our numerator now become? Our constant is 3. Okay, so 6 is equal to 6 over 1, which is equal to 18 thirds. It's all equivalent fractions for the whole number 6. This stays as is. So now, technically, it's how many in what in what. You got to get to this as well. Anna. Good girl, yes. See how this becomes kind of cumbersome? You need at least 18 lines. What's this first line? Fractional. Ready? 2/3, but I'm not going to put the denominator. 3/3, 4/3, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Where's my go-to? Still. My line. Lead by column. Yep. And obviously every line's a lead. I'm not going to do it, but how many leads you got? 18. Takes a long time. Now we can cut to the shortcut. If the question asked how many fourths in 6 miles using the shortcut, what's the answer? See? 24. And as Andrew said, you're taking the whole number and multiplying by what? We'll get to reciprocals, but right now, he's right. You're taking the whole number and you're multiplying it by the denominator of the second fraction, or the second, or the fraction, there's only one fraction. Whole number multiplied by denominator. Which, in essence, is pretty close to what you're actually doing. You can stay here if you want. Let's see later. Forgot what day it was, Eric. In essence, what we're doing is keeping the first fraction, or first number, a whole number, and we're taking the second fraction and we're turning it upside down, which is called the reciprocal of that fraction. Okay? Which is what we're going to build on. So if we take this 6 divided by 1/4, what you're really doing is taking 6 times, and the reciprocal of 1/4 is very simply turn it upside down, and what do you get? 4/1. Now, in essence, really to do this, the whole number 6 is what as an improper fraction? Fluky. 6/1. And then you get 6 times 4, which is 24. Remember, it's tops times tops, bottoms times bottoms. Over 1, which is equal to 24. Now, I have to ask you a question. Tell me if you remember this. We're going to go back to ratios. Do you remember when we had equations and ratios?
Yeah.
Y equals x divided by 3 was the same as doing what? See, this is good. I see hands. You guys remember. Say it. Right. That's where that reciprocal comes into place. I change my division to multiplication, and I take my 3/1, and I invert it. Vocabulary word, ELA, by the way. Okay? So it's the same exact thing. Now you say to yourself, okay, well, why do we still have to show this when all we really need to do is this times this? And the answer is, I want you to get to that idea of doing a reciprocal fraction, because eventually you'll get this. It's not, there's no whole number here. There's no whole number to multiply by 17. But if you keep this the way it is and multiply by 5/17 reciprocal, which is 5. You will get it right every single time. I have to do one more thing with this eventually, and we'll get to it, and that's change it back into a mixed number, because right now it's top heavy. But we'll get to it. We actually get to this by lesson 7, but there's no lessons 5 and 6. It's a skip. So tomorrow, I think tomorrow, lesson 4 will be a breeze if you get this idea. And then all we do in lesson 7A is practice this idea. All right. Everybody try A through E on your own. Oh, there is a mistake on this one. You're right. It's already been changed. This needs to be what? Leave this the way it is. I'm going to change it here. There's a mistake here. I'll just give you the change. I don't want this to confuse you. It should be 8 divided by 1/6. You'll see. Okay. Do A through. I'll tell you what. Do A through D. Don't even worry about modeling it at this point. So you get the idea. A through D. Z, come on up. Hold on, ready? Here's Z.
Okay. I am going to do 1/6 to 8. Because how many 1/6 just and then as the division expression we flip it. No, division is 8 divided by 1/6. And as the multiplication you flip it. 8 over 1 times 6 over 1. And then flash it at 48.
Where's that come from? Newfield. Is that where Dad's at? Newfield. That makes sense. Everybody there? Bottom of page 8. We were okay when I was looking at the sheet. We were okay with the first 3. First 2, I should say. Because many of you are taking the shortcut and multiplying this times the denominator and getting your 45. 40 times 5 is 200. And that shortcut will work if the numerator's 1. But what I really want you guys to get into the habit of doing, and you have to show it this way, is show me that you know that multiplying or dividing by the fraction is the same as multiplying by its reciprocal. When you invert this upside down, you now get 5 over 2. Agree?
Yes.
The answer is not 80 anymore. It's not 16 times 5. What you need to now do is take the 16 times 5. That's going to make your 80. If your denominator is no longer 1. What is it? It's 2. And 80 over 2, when you change it back into a whole number, becomes what? It's like the opposite of changing a mixed number into an improper fraction. You've got to say to yourself, 2 goes into 80 how many times? In this case, it's exact. The answer for this is 40.
I thought it would be 82.
Do you see why now, though, it's 40?
Not really.
Okay, so let's go backwards. Do you see why I have 16 over 1 here? Do you see why dividing by 2/5 is the same as multiplying by 5 over 2? That's what we mean by reciprocal. You have to turn the second fraction upside down. Have to. Okay? When you do that, it's going to create 16 times 5 is 80. And 1 times 2 is 2. 80 over 2 is an improper fraction. The way you change an improper fraction back into a mixed number, it's technically 2 numerator into D denominator. And it goes exactly 40 times. That's our answer. Alright? Reciprocal fractions is the easiest, but it takes some practice. Luke.
So I kept it in division, and I saw that it was 16 over 1. And I did it constant. I did times 5, so I did 16 times 5, 80 over 5, and then I just divided it like that, and I got 40 over 1.
You could do it that way too. What he's saying is this. Changed it into Hunter's favorite. Template ratio, fine. That way also. Okay? Okay? But now when you did that, you get 80 over 5, but our answer is 40, so what did you do after that? I lost you.
I did 80 over 5 divided by 2 over 5.
So you know what you did? You know what you want to do in this? You wound up making common denominators.
Yeah.
And then dividing the numerators.
Yeah.
You can do that, but that's actually the longer way to do it. It really is. That was before I taught you reciprocal fractions, without a doubt. Making common denominators and dividing numerators was the shortest way. This way is even shorter. Okay? And as you'll see, when you get to this, if you're going to get to this in 3 lessons, guys, you'll get this. 3 2/3 divided by 1 1/8. Okay? If you understand how to do reciprocal fractions, you'll be able to do this pretty quickly. We're going to get to that. Okay, what about this? This is why I want you to show the work. It's not, now we have to fraction divided by a fraction, but the reciprocal rule will always work. 2/9 divided by a half is the same as 2/9 times what? 5. Tops times tops. 2 times 2 is the same.
4.
9 times 1. 4/9 is the answer. 4/5 divided by 6/7 is the same as 4/5 times, what's the reciprocal of 7? So you can say over and over again. Reciprocal. As much as I want to use Unverzachtian theory, it doesn't translate well when you go to 7th grade. It's called reciprocal fractions. I want it to become part of your vocabulary. 7/6. Now you'll see you have to do one more extra step here. But 4 times 7 is 5 times 6.
30.
And I would give you credit for this, but I also want you to start getting into the habit of reducing fractions to lowest terms. This is why remember we did divisibility rules? This is why it's so important, because there's a number that will go into both 28 and 30. 28 and 30 is divisible by what common number? When you reduce it or simplify it, 14 over 15. Okay? Now the good news is once you kind of get this idea of reciprocal fractions, all we're going to do over the next week is just practice it like crazy. Okay? Let's go to day 2, which is really just period 2 at this point. I want you to read the word problem quietly to yourself, and I'm going to ask you, why is this one a little bit different from what we've been doing? Go ahead. So you see why it's different. Technically, yeah, we have to find the whole. What they're asking us is they're telling us that she's used 9 cups of flour to bake bread. That's not the whole entire amount. That's only 3/4 of the total amount. They're telling you or asking you, what was the total amount if 3/4 of that total is 9? Okay, now there's a few ways we can do it. You can model it. This is showing you 3 shaded boxes out of 4, right? This is my 3/4. Does everybody see it modeled as a fraction bar? Okay, here's my next question. This shaded part, if you could think back to your tape diagrams, it's all about getting the value of each box. That 3 shaded boxes represents how much? 10. Right, it represents 9, which is the cups for the bread, right? Think back to ratios. If 3 pieces are worth 9, what's the magic number? Oh, you get a ratio. Go. Yeah, magic number is 3. Just like in any tape diagram, that's good for every number. Add up all your 3's, and that's going to give you the total. Constant is 3. 12 cups. I'm going to show you all the ways. How'd you do it?
I took 9 and I put 9 over 1, and then I take 3/4 and put 4 over 3.
Okay, we're going to get to it, because it will work that way. Okay? The other way that you could do it, Hunter's favorite, is TRF. Part to whole. I still want to show it to you because really it comes down to using whatever works best for you. If you're a model person and you're like the tape diagram, fraction bar, whatever you want to call it, then use it. If you like TRF like this young man right here does, here's my template, part to whole. Ratio and fraction, same thing. 3, 4. Equals. The 9 is it part or the whole? Part. It goes top. The constant. You got the whole 12. Third way, on Versackian theory, okay, this is why ratios and fractions are so closely related. Let's just see if it works using reciprocal fractions. 9, amount of cups, divided by 3/4. In any division problem, dividing by 3/4 is the same as multiplying by its reciprocal, which is what? 4/3. Joe, 9 times 4. 1 times 3. Top heavy number. If this number's bigger, it's improper. 3 goes into 36 exactly how many times? Which is 12. Okay? You can use TRF, that's fine. I still think, well, I'm not going to tell you what I think is best. Okay? It's not going to be a one-size-fits-all type of math curriculum. You do what's best for you. I kind of want to show you one more other thing. Whole number divided by a whole number. Just something cool. What's 6 divided by 2? Christina, can you close that door? 3. 3, right?
Yeah.
I just want to show you that reciprocals will work with dividing by a number is the same as multiplying by its reciprocal. What's the reciprocal of 2? If this helps you. What you need? Ready? Watch and be amazed. 6 times 1. 1 times 2. 6 over 2 is an improper fraction. Whole number is 3. It works. Okay? That's why it works, and it will work for everything. It is definitely my favorite way when the division problems get complicated. For you to get an answer quickly, it's kind of tough to model 3.5 divided by 4 and 7/57. Okay, when the numbers get cumbersome, if you understand how to change any improper fraction or any mixed number into an improper fraction and then multiply it by its reciprocal, it will always work. You want to try this one on your own? Well, let's do this one together. George is having a birthday party and he has currently fed 27 of his guests. Underline 27, circle it, box, get the okay. That number, if this was 3/8 of the total, how many guests will George feed in total? Are they asking us to find the part or the whole? Find the whole. And I want to add one more other thing to this. It may confuse you for your upper level thinkers. It might help you, or it's just another way to look at it. They're really asking you, what number times 3/8 is 27? Or I'll take even more advanced, some of you will see it right away. What number n times 3/8 is 27? Okay? Not that we're going to put this into play or use it, but when we get into algebra, when we get into mod 4, you're going to start to look at these a little bit more extensively.
Oh, I know it now.
Okay, it just maybe helps you see, okay, what number times 3/8 is 27? You may even be able to do that in your head, but we can model it. We can certainly do part to whole relationships. We can definitely use reciprocal as a How many am I going to shade? Here's my 3. This shaded region of 3 boxes represents what whole number? Go back to the word problem. Let's wake you up, man. You're on fire. Go again. You owe me back taxes. 27. Alright, somebody else. Finally. How are we doing? What's the magic number for each box? 27 into 3. Or I should say 27 divided by 3. 7 times 2 is 21. A little bit off. You got it. Magic number's 9. It's good for every box. How many boxes were there?
8.
9 times 8 is? You can feed a lot of guests, 72. Part whole. All you. First ratio fraction, which was, and don't turn it upside down. 3/8. Constant. Remember, the constant is the magic number. Here comes reciprocals. Ready? 27 divided by what fraction again?
3/8.
Put a 1 over this because we're going to need it. What's the reciprocal of 3/8? Joseph, were you shown how to do cross reducing? All right, we'll get to it. I don't want to let out all my secrets, but I could. You know how to do it? Rather than doing 27 by 8, we could take even a shortcut to the shortcut to the shortcut. Viv, you remember? Right. If you look at your cross products, if there's a number that goes into both 3 and 27, you can use that number. What number goes into both? Again, divisibility rules again. 3 goes into both, right? Hold it up right now. Here's your fingers. 3. Say to yourself, I actually want you to do it this way because kids can get really confused with this. 3 goes into 3 how many times? Cross it out, make it a 1. Keep those same three fingers up. 3 goes into 27 how many times? 9 times 8, 72, over 1, which is 32. If you don't do that, it'll still work. It just takes longer. 27 times 8. I think it's 216.
Yeah.
It's pretty good on my hand to do that quickly in my head, right? I wasn't looking at a key. And 3. Now, you got to take your 3 and figure out, all right, how many times does 3 go into 216? It will work out evenly in this case.
72.
It'll work. Okay? All right, here's your assignment. Now I didn't look at my key. I put this on the block as well. How much time do you have? About 25 minutes? 20 minutes?
20.
Okay. Pages 11 and 12, right? 11 and 12. What? I thought I put it up there, no? Yeah, okay. Ready? I'll get to it. Page 11 and 12. Those that need to check with me, otherwise, just hanging out if you actually then, after you check with me, I'm going to get your exit ticket, which I believe, double check. Period 3 is a little bit, yeah, you guys, your exit ticket is it's 1 exit ticket below. There's 2 sides to it. But now listen, it encompasses lessons 2 and 3. So look, the first question, you do have to model it. You can underline. Then, when you get to the bottom, it's reciprocals. And then the back side, it's just parts of the whole thing. So it's a little bit of everything, so you may have to look back. This you have to do on your own, though, right? Here I've checked 11 to 12.